So this week, for the internet topic, I had some difficulty finding articles relating to the internet, so I went more of the Internet of Things route, which I'm not sure if that was the right approach to it, but that's what most of my articles involve. So my first article was using ICN with 5G networks. Basically, this article focuses on the information-centric networking, or ICN, in order to amplify the abilities of 5G networks. So the ICN has three main principles, which are location-independent name-based communication, dynamic intelligent routing, and secured in-network content caching. There's an ICN model used in this article, the NDN, or Named Data Networking model. This model uses two types of named messages. So there are the interests, which request content, and the data, which carries the content. And they basically combine these with a 5G architecture. And the 5G architecture is cloud-based with a programmable core network. Traditionally, network functions aren't implemented in an operator-owner node, but instead as a virtualized function. So these 5G plans use virtual functions, and then this deployed by third parties. And then this article suggests combining it so that the 5G network could benefit from the name-based forwarding and caching capabilities of the ICN networking. The article had a bunch of technical information regarding the setup of their network and how they would go about doing it. I didn't understand a lot of it. However, they then did a testing scenario with a parent streaming a video for a child in the backseat of a vehicle, and I think from what I read, it came out okay. They didn't actually explicitly state how well it works. They kind of just stated the technical jargon, which again was a little bit difficult for me to understand. However, the article, other than the technical stuff, was pretty easy to follow, and it was an interesting concept to kind of give us, right now we kind of work on 4G networks, so to give us a 5G network that would benefit a lot of people in the streaming department, which is what a lot of people like to do. So I think we'll be seeing a lot more of the combination of 5G networks and ICN networking in the future. My next article focuses on ICN slicing with the Internet of Things Edge. So the Internet of Things Edge, excuse me, it has the main purpose of interacting with the real world to gather environmental data as well as work with smart systems in the real world, so that these operations don't have to necessarily work through a centralized cloud. The working with ICN slicing then would give some benefits to this, including simpler stacks on resource-constrained devices, in-network caching, and inbuilt data provenance. So the article then combines it using a lightweight stack connected with sensors to an IoT to build a network. So this then allows for clients to set realistic policies using their legacy handheld device. This IoT slice can then coexist with other service slices that work with varying classes of applications. In general, network slicing allows for newer network functions and architectures, such as the ICN information-centric networking, to coexist with IP-based services. So a lot of times with ICN, it doesn't work as well as it could if all the networks aren't cohesive with ICN functioning. So this slicing allows it to coexist with an IP-based service. This article then demonstrated its potential deployment of this using devices that run ICN protocols assisted by a network service. This article is relatively difficult to follow. There was a lot of information. It was a shorter article. It was only a couple pages long, and they kind of just jam-packed everything together, so there wasn't a lot of fluff information. Not that fluff information was needed, but it would have been nice to have a little bit more background and a little bit of extra information explaining things from my perspective, anyway. My next article involves the Internet of Things and smart healthcare monitoring. They propose a new architecture involving the Internet of Things for storage and processing for healthcare applications. So this model focused on two sub-architectures. The MFR architecture is a meta-fog redirections architecture, which collects and stores sensor data from sensor devices. So like a heart rate monitor would be a sensor device. And then the other one is a GC architecture, grouping and choosing. This architecture secures the integration of fog and cloud computing. It also has the ability for key management and data categorization for security purposes. In this situation, especially with healthcare, they want the information to be fairly secure for HIPAA reasons and whatever else. So that's what the GC architecture does as well. The architecture is split into three different phases: data collection, data transfer, and data storage. Sensors collect the data regarding various things such as respiratory rate, heart rate, blood pressure, blood sugar, body temperature, and whatever else it collects. The data is then stored in the cloud, and then it moves to the proposed Internet of Systems monitoring system, kind of for analysis, but it basically sorts through it so that healthcare people don't have to. With this type of device, there's a lot of information that is sent, especially if you're wearing a heart monitor for a heart disease purpose versus just seeing what your heart rate's doing when you're exercising. You want to collect a lot more data. You want a lot more intricate data collected. So it takes a while to go through that and sort it out and see what's important and what's not. And moving it to this Internet of Things direction would help with that, so that the information would be easier to sort through from a healthcare perspective. This article was somewhat difficult to follow. There's a lot of information in it. It was a pretty long article too. However, I found the premise to be pretty promising, especially if it's in a more serious context, such as heart disease, or if you're monitoring for heart attacks. You're gonna want that information to be quickly sorted through, and I think this could definitely be a way of promoting that. My next article focuses on strategies for loop prevention, a loop prevention forwarding logic in a hybrid information-centric networking model. So this forwarding strategy for ICN and hybrid ICN. These networks involved interest requests. So kind of like I mentioned before, there's an interest in a data. So the interest requests get sent out in an ICN network, and they're sent to forwarders. But there's a problem that exists with this, where requests can be sent back to the forwarders, and the forwarder's main goal is to direct an interest request to the nearest representation of data. So the problem that they have is kind of like a loop being created, which I'll talk about in a second. But so they forward to the nearest representation of data, which is difficult. First, it's difficult with networks that aren't fully ICN compatible. So this is where hybrid ICNs come into play. Hybrid ICN network models work with objects that are represented as IP version 6 addresses. So that solves one of the problems that they're having. However, the use of dynamic caching also causes an issue with dynamic caching, there can be multiple representations of this interest data that you're searching for. So that means that there are multiple pathways to the same object. So the problem with this then comes into play where you can either not find something and get looped back to a forwarder, or there's just so many options that you're just in this mini loop because your interest is always being sent back to this forwarder. This article was incredibly difficult to follow. However, it did have good background information regarding the ICNs and you know, interest requests and forwarders. It set it up nicely in that respect. However, the rest of the article, it wasn't poorly laid out, but it just didn't flow very well for understanding it. So this is pretty much all I got from the article. I'm pretty sure whatever they were doing worked out for them. They seemed positive. However, the conclusions weren't even that explicitly stated. My last article focuses on a caching scheme for ICN and IoT networks. So it's a combined network between these two, and it's focusing on an in-network caching system. The main goal of this is to improve energy consumption and efficiency of IoT networks. So by caching in this way, using different nodes, devices are able to reduce their overall energy consumption. This also implements an auto configuration mechanism, which allows this caching scheme that they're suggesting to adapt and kind of automatically update. So it can adapt to a request rate or whatever else, so that it'll use more energy when it needs to, less energy when it doesn't need to. Their proposed system is the Lifetime-Based Cooperative Caching Scheme, or LCC scheme, and they found that it outperformed the current schemes that are available for energy reduction. I can't remember if it was by 40% or if it was 40% more accurate at doing this, or more efficient, or if it was overall 40% efficient and the other schemes were less efficient than that. I can't remember. However, they did find that it was more efficient in that way. This article is incredibly difficult to understand. There was a lot of technical jargon, a lot of equations involved and included. However, from what I gathered from it, from what I actually understood of it, it seems like a good idea for those with IoT devices, because they save battery life, and that's one of the things that people really seem to enjoy, is having a longer battery life. So I'm not really sure if I covered the internet topic all that well, but for next week I'm going to look into using the internet or Internet of Things for storing and monitoring in healthcare situations. I'm going to try to focus on sensor devices, but I'm not going to limit my search to them. It's probably going to be the only thing that I'll find is sensor devices, but however way that goes, I will kind of look into that and see if my direction changes when I start looking into that.